Hello, this is the third lab practice of the course of application materials, and it is named Microstructural Changes During Arc Welding. The objective of this practice is to evaluate the microstructural changes that a weld steel experiences through the process of electric arc welding in the different zones that make up the welding cord. The equipment and materials that we use in this practice was safety equipment, welding machine, a resist disc, mounting press for metallographic specimens, metallographic microscope, the Vickers durometer, the polishing machine, then the milling machine. And well, the materials were steel plates, electrodes for welding, silicon carbide grades, colloidal alumina, and phenolic resin.
We took two metal plates and welded them together.
We cut the welding zone with the cutting machine, and we cut a basic zone.
We take our piece of steel and introduce them in bakelite.
And we do the metallographic preparation in order to have mirror finished.
After, we did the Vickers hardness test in both samples.
And then we made the chemical attack in order to look the grains of both samples in a microscope in different magnifications.
The results of this practice were the ones obtained in the hardness test. We used the Vickers durometer. We measured the diagonals of the indentation made by the durometer, and we took the average, and with the tables we determined that the hardness was of 197. Then we repeat the same procedure for the sample, in the welded sample, and we obtain a hardness of 151. We can observe that it decreases a lot. This means that the indentation in the welded sample was made in the fusion zone. Here, in this zone, the mechanical properties decrease because the grains increase in size, and we could prove this when we observe the samples in the microscope. We could see that the grains in the welded metal are a little bit bigger.
There are several advantages and disadvantages to welding as to other methods to join materials. For example, welding is a permanent process. It can allow different grades of materials to be joined together. Materials can be joined side by side instead of overlapping. In addition, there are no bolts that can be loosened, and since there are no bolts, welding is usually lighter than joining with bolts. In addition, for some applications, a leak-proof joint is necessary, which welding can give. However, the disadvantage of welding is that it is a permanent procedure, and so the parts cannot be disassembled if that is a requirement. In addition, in some parts, the access for welding may be impractical, and welding leaves a heat-affected zone, which in some cases may not be tolerated because of the use of the material. In steels, it is important to know the carbon equivalent or the percentage of carbon in the steels, as that will determine the weldability in it. For example, a steel with a higher grade of carbon will be harder to weld, and more caution will be needed than one with a lower carbon equivalent.
What type of structural changes are expected in the welded area? Well, in the welded area there are two zones, the fusion zone and the heat-affected zone. The fusion zone, after a joint is welded and allowed to cool, the following happen in the fusion zone. Formation of columnar grains that are long and parallel to the heat flow path. Grain structure and size depend on alloy, welding process, and filler metal. Coarse grain produced. Thus, the fusion zone has low strength, low ductility, and low toughness. Meanwhile, in the heat-affected zone, high residual stresses from localized heating causing differential shrinkage, stresses that then lead to distortion and warpage, a reduction of ductility of a degree hardening in this zone may lead to cracking and deterioration of the toughness properties of the part mainly in this zone. And tempering and quench and generally heat treatments they lost their strength in this zone generally. We can relate this in the practice as we observed that the welded zone has bigger grains but lower hardness.
We can see that the fusion zone and the heat affected zone have bigger grains than the basic zone. Also, we can say that near to the fusion zone, the grains are bigger.
In material behavior, we saw that a bigger grain size is a low mechanical properties. Then the fusion zone and the heat effect zone has a low properties than the basic zone.
For example, we can say that crack propagation is bigger in this grain that has a bigger size than in these little grains because we say that the crack propagation is bigger because we have a bigger distance between these grain boundaries than a little grain size.
In the heat effect zone, we have a low strain and low toughness than the basic zone.
For this practice, we used a welding method called shielded metal arc welding, which uses a flux-covered electrode connected to a power source to weld a workpiece. This workpiece is also connected to the power source and to ground. This method allows welding to be done in all positions, including overhead, and it is mostly used for construction work, repair work, maintenance in steels. It is a relatively cheap method that uses a low voltage and high amperage. In order to have an even weld, a few factors need to be considered. These are the power source, whether it be AC, DC, the current, and the speed of the weld. For example, a DC power source can be preferred for a thinner sheet as it gives a more steady arc, while an AC power source can be used for thicker pieces as it can have a deeper penetration. In addition, the speed and the current need to be matched to the workpiece. A higher current can allow a greater speed, but it can also mean that the weld is less steady, less even. The flux that coats the electrode is used mainly to protect the weld pool from the atmosphere. When the flux is used, it creates a gas shielding which prevents other gases to come into the weld and contaminate the workpiece. However, it creates a slag on top of the material that should then be removed, as this slag can damage the material. In addition, it is also used to help with the ignition of the weld pool, and it can sometimes have minerals to enhance the mechanical properties of the material. In conclusion, I learned that welding can affect the properties of a material, and this should be known because otherwise the material can have a weakness inside it in the weld, which could damage the material in its application. In these cases, other treatments like normalizing or annealing should be done to recover the original properties. And
in this practice, I learned how arc welding affected a steel plate through all the different zones, like the fusion and heat affected zone.
In this practice, I learned the differences that can make the welding in a steel, a difference in hardness, the difference of mechanical properties in general, the different zones of the welding sample.
With this practice, I really understand how temperature can change our characteristics or in our materials. Also, I learned how the different parts that a welding have. For example, the fusion zone, the heat affected zone, and the basic zone, and all the difference between these phases, although they are the same material.
in this practice, I can learn about the difference between the heat effect zone and the normal zone. It's important because if we did welding, we have different mechanical properties that can affect in our design or in our application.